The BMW iX5 hydrogen, developed on the basis of the current BMW X5, was first unveiled as a concept at the IAA show in 2019. Initial prototypes were then made available at the IAA Mobility 2021 for visitors to experience in action as shuttle vehicles. Its hydrogen fuel cell system is further proof of the BMW Group's leading development expertise in the field of electric drive technologies. The BMW Group is systematically pushing forward with development of hydrogen fuel cell technology as an additional option for locally emission-free individual mobility in the future. The BMW Group produces the highly efficient fuel cell systems for the pilot fleet at its in-house competence center for hydrogen in Munich. This technology is one of the core elements in the BMW iX5 hydrogen and generates a high continuous output of 125 kilowatts/170 horsepower. A chemical reaction takes place in the fuel cell between gaseous hydrogen from the tanks and oxygen from the air. Maintaining a steady supply of both elements to the fuel cell's membrane is of crucial importance for the drive system's efficiency. In addition to the technological equivalence of features found on combustion engines, such as charge air coolers, air filters, control units and sensors, the BMW Group also developed special hydrogen components for its new fuel cell system. These include the high-speed compressor with turbine and high-voltage coolant pump, for instance. The BMW Group sources the individual fuel cells from the Toyota Motor Corporation. The two companies have enjoyed a partnership characterized by trust for many years and have been collaborating on fuel cell drive systems since 2013. Fuel cell systems are manufactured in two main steps, based on the individual fuel cells. The cells are first assembled into a fuel cell stack. The next step involves fitting all the other components to produce a complete fuel cell system. Stacking of the fuel cells is largely a fully automated process. Once the individual components have been inspected for any damage, the stack is compressed by machine with a force of 5 tons and placed in a housing. The stack housing is manufactured in the light metal foundry at BMW Group plant Landshut using a sand casting technique. For this, molten aluminium is poured into a mold made from compacted sand mixed with resin in a process specially designed for this small series vehicle. The pressure plate, which delivers hydrogen and oxygen to the fuel cell stack, is made from cast plastic parts and light alloy castings, also from the Landshut plant. The pressure plate forms a gas-tight and watertight seal around the stack housing. Final assembly of the fuel cell stacks includes a voltage test along with extensive testing of the chemical reaction within the cells. Finally, all the different components are fitted together in the assembly area to produce the complete system. During this system assembly stage, further components are fitted, such as the compressor, the anode and cathode of the fuel cell system, the high-voltage coolant pump and the wiring harness. In combination with a highly integrated drive unit using 5th-generation BMW e-drive technology, the electric motor, transmission and power electronics are grouped together in a compact housing at the rear axle, and a power battery with lithium-ion technology developed specially for this vehicle. The powertrain channels maximum output of 295 kilowatts, 401 horsepower onto the road. In coasting, overrun and braking phases, the motor also serves as a generator, feeding energy back into a power battery. The BMW iX5 hydrogen is being built in the BMW Group's pilot plant at its Research and Innovation Center, FIZ, in Munich. This is the interface between development and production, where every new model from the company's brands is made for the first time. Around 900 people work there in the body shop, assembly, model engineering, concept vehicle construction and additive manufacturing. They are tasked with ensuring that both the product and the manufacturing process are ready for series production. In the case of the BMW iX5 hydrogen, specialists in hydrogen technology, vehicle development and initial assembly of new models have been working closely together to integrate the cutting-edge drive and energy storage technology. The hydrogen needed to supply the fuel cell is stored in two 700-bar tanks made of carbon fiber reinforced plastic, CFRP. Together these hold almost 6 kilograms of hydrogen, enough to give the BMW iX5 hydrogen a range of 504 kilometers, 313 miles, in the WLTP cycle. Filling up the hydrogen tanks only takes 3 to 4 minutes, so the BMW iX5 hydrogen can also provide the driving pleasure for which BMW is renowned over long distances, with just a few, short stops along the way.